We'll be going over 5.5, question number 12. Find the basis B for the span for the given sequence S of vectors that is efficient for the purpose of finding coordinate vectors. For each vector V and S, compute the coordinate vector of V with respect to B. So for number 12, S is going to be the vectors in exercise 4. And so essentially, to find the basis for the sequence of vectors, you have to turn it into a matrix and find the reduced echelon form, which is what I did right here. I plugged it into a calculator. And so essentially, the book states that every column that is a pivot column would be in the basis. So after getting echelon form, the highlighted columns with pivot columns would be in the basis. And this would give us our basis right here, which is the first, second, third, and fifth vector from the sequence of vectors. And so that's going to be for A. And for B, to find the coordinate vectors, it's going to be easy for the V1, V2, V3, and V5, because since those vectors are already in the basis, all we have to do is set one vector, multiply one of the vectors in the basis by 1 and multiply the rest by 0. So basically those the coordinates of vector V1, V2, V3, and V5 are already given right here. And so we would need to solve for the coordinate of vector 4 and 6. And so to do that, you would just get the basis and then put the vector in this case vector 4 on the right, and so you would make the argument to matrix. And so I just did row reductions and I just solved. And so what I got was that the coordinate vector for vector 4 with respect to the basis would be 0, -1, 2, and 0. And so I tested that out and that one did work. And for the second one, it's the same thing. You would put the basis on the left and then the vector you're trying to find the coordinate for on the right, and then just get the reduced row echelon form, which would give you your coordinate vector. In this case, I'm not sure if I did the row reduction right, but in this case I got a coordinate vector for vector 6 is 0, 5/2, -5/2, and 1/2. And that's the answer.